The difference quotient is f of x plus h minus f of x, the whole thing divided by h. Let's see what that really means. Again, we see the difference quotient is f of x plus h minus f of x all divided by h. So again, what does this really mean? Well, if we were to have the given function f of x equals x plus 3, and say I were to say that said f of 3, well, what would we do? We would simply replace x with the given value of 3 and continue with the expression. And so we would say 3 plus 3 equals 6. But what if instead of a 3 I said find f of negative 2? What does that mean? Well, again, it means replace x with the given value of negative 2. What if it said f of, say, 1/3? Well, what does that mean? Again, it means replace x with the specified value of 1/3 into the function. Well, how does that apply here? Well, if I say find f of x plus h, what am I asking you to do? I'm asking you to replace the original x with the specified value of x plus h and continue with the function. And so, when the problem says f of x plus h, this is your new function, whatever your new one is. And the f of x is your original, meaning it's the original function that was given to you. Everything else is not necessary. Those are the only two pieces we would need. And so in this case, our function would be the new one, which was x plus h plus 3 minus the original function x plus 3 all over h. Example 6. Construct and simplify the difference quotient. First off, notice the key word. It does tell you specifically to use the difference quotient. So by default, that means we are talking about f of x plus h minus f of x all over h. So in that phrase, it means this automatically. Okay, so in this case we have f of x equals x squared minus 2. This is our original. And so what we need to find now is our new one. So our new one is always going to be the value, the f function, but this time x plus h is always going to be your plugged in value. And so anytime you see an x, you now plug in x plus h. Once we've plugged it in, we want to go ahead and take the time to simplify as much as possible. And so order of operations comes up. First off, we have grouping symbols, but there's nothing we can do inside. So we move on to exponents, and since we have x plus h squared, we are going to take care of that. X plus h squared means x plus h times x plus h, and we still have that minus 2 at the back end. Now multiplying x plus h times x plus h means we are going to distribute. So x times x is x squared, x times h is xh. Now h times x is xh, and h times h is h squared, and then we still have that minus 2 tagging along. Then we want to see there's nothing else we could multiply or divide, so again moving down, the next step would be to combine like terms using addition or subtraction. Now notice we do have two like terms, so those can be combined. We keep the x squared. And now how many xh's do you see? Well, we have 2, so we write it as 2xh. And then we still have plus h squared minus 2. So this is going to be our new function. So we have our original, which is right here. So here's our original. And then we have our new one. So now we just need to simply plug those into the difference quotient. Now, remember that the difference quotient is made up of two parts. Okay, it is always going to be your new one minus your original, whatever it happens to be. So in this case, we look back at our new one, and we're going to take this whole entire thing and put it into the new function. And so carefully we write x squared plus 2xh plus h squared minus 2. And then now we carefully plug in our original function, which was x squared minus 2. Once you plug them in, you now have to simplify and look at the expression as a whole. Again, order of operations. In the top, we do have grouping symbols. The first grouping symbol we see is the new function, so we check out in front. Is there anything that we can distribute? Anything that we can do? And it turns out there's nothing to distribute, so we simply keep the new function exactly as it is. So it will stay x squared plus 2xh plus h squared minus 2. Now we take a moment and we look at the old function, the original function, sorry. And there's nothing we can do inside that grouping symbol, but because we have a minus sign in front, that is going to distribute and do sign changes for everything afterwards, which means we now have a negative x squared and we now have a positive 2. Once we've done that, we've gotten rid of all the grouping symbols, and now we are ready to start combining like terms, simplifying everything we have in the numerator. So in the top, notice we have x squares and we have x squares, but with the positive x squared minus the x squared, those cancel. Now we look for xh's. Notice I have an xh right here. Do I have any more xh's? And I don't. So I'm going to keep that as 2xh. Now I continue on, and I see that I'm running out of colors. Alright, I have an h squared. Do I have any more h squares? No. So we keep the h squareds. We continue on. I notice I have a negative 2, a constant, a plain number, and I have another constant. Well, a negative 2 plus a 2, what happens? It cancels, it disappears, it goes bye-bye. And so we're left with just 2xh plus h squared over h. Well, we need to simplify this because this is a fraction. The easiest thing is just to separate this into two separate terms. So we write it as 2xh over h plus h squared over h. So we rewrite the numerator individually over the same denominator. And then now, if possible, reduce all fractions. Notice we have an h in the top and in the bottom, so those reduce, leaving me with 2x. Now the second fraction, keep in mind, h squared really means h times h. So this fraction is the same thing as h times h over h, which means can anything reduce? And it can. Turns out one of the h's in the top and one of the h's in the bottom reduce, reducing that whole value into an h. So in this case, your final reduced simplified answer is 2x plus h. Example 6b. This time the given function is f of x equals 3x squared minus 2x plus 1. And we're being asked to construct and simplify the difference quotient. Again, difference quotient means f of x plus h minus f of x all over h. That's what it's referring to. So the first thing you need to do is you need to find your new equation, which is when you substitute the value of x plus h in for x. So identify where all your x's are, and we're going to rewrite this. So 3x squared minus 2x plus 1. Again, I strongly suggest you write parentheses first before you actually plug in the value. Now that I've got it set up, now plug in x plus h. And you have the expression. To make life easier, we want to go ahead and simplify this as much as possible. So we do order of operations. Notice we cannot do anything inside the parentheses, but we do have exponents. I do suggest you just work this out. X plus h squared, what does that really mean? Well, it means x plus h times x plus h. And then we keep everything else exactly as it is. And then from here we need to go ahead and multiply. I would suggest you go ahead and multiply x plus h times x plus h first. So x times x is x squared, x times h is xh, h times x is xh. Sorry, my pencil's going a little haywire. xh, h times h is h squared. So all of that was the result of this. Everything else remains the same. Now we still have more multiplication. Now we are going to distribute the 3. Oh, I'm sorry, I got ahead of myself. We're going to go ahead and combine like terms within the parentheses. Notice we have an x plus h and an x plus h. Everything else remains exactly the same. Now that we've combined the like terms within the parentheses, now we move on in the order of operations to multiplication division, which means we now distribute the 3. So that becomes 3x squared. 3 times 2xh is now 6xh. 3 times h squared is now 3h squared. We quit distributing because we're at the end of the parenthesis. And now notice we have not just a 2 in front of this parenthesis, but we have a negative 2. And the negative 2 needs to distribute to everything of that parenthesis set. So pay attention to your signs. And so this turns into negative 2x and a negative 2h. And then again, we still have the plus 1. Looking here, do we have any like terms that we could combine? And it doesn't look like it. So what that means for us is that this, all of it, is the result of your new function, while all of this is your original function. And so now we have enough information to start to find the difference quotient. Your difference quotient is always going to be your new minus your original. And so we carefully plug in our functions. Our new function is 3x squared plus 6xh plus 3h squared minus 2x minus 2h, and I ran out of room, plus 1. Give yourself plenty of space. There's your new function. Right, minus the original function, and the original function was 3x squared minus 2x plus 1. Okay, so there's the setup. From here, we just need to kind of mesh it all together. So again, in the first parenthesis, the new function, we check and see, is there anything in front to distribute? Is there any reason to keep those brackets? And the answer is no. So now we can confidently write it as it is. 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 1. Okay, so we checked the first parenthesis set. There's nothing to distribute. Now we check the second one. And notice in front of the original we have this negative, which needs to distribute, and it does a sign change to everything thereafter. So this now becomes a negative 3x squared and a positive 2x, and now a negative 1. And there's your function clear of grouping symbols, parentheses, so now we are ready to start combining like terms. So let's just start in order. The first one I see is 3x squared. Do I have any more x squareds? It turns out I do. 3x squared minus 3x squared, those cancel. They undo each other. They're gone. Poof, disappeared. Next I have a 6xh. Do I have any more xh terms? And it turns out I don't, so I keep 6xh. Now I have 3h squareds. Do I have any h squared terms? And it doesn't look like it, so it must stay as 3h squared. Next I have a negative 2x. Do I have any more x terms? And it turns out I do. Negative 2x and a positive 2x, they cancel, they're gone, they're eliminated. Bye-bye. Alright, next I have my negative 2h. Do I have any more just plain h terms? And it doesn't look like it, so he has to stay. And lastly, I have my constants, my plain numbers, and I have a 1 and I have a negative 1 at the end, so those cancel. They disappear. They're gone. And so this is our result. 6xh plus 3h squared minus 2h. Now the whole thing is over h. So to simplify, I strongly suggest you simplify and write these as individual fractions. 6xh over h plus 3h squared over h minus 2h over h. This just prevents a lot of errors that I've noticed. And so now we carefully start to simplify. In your first term, 6xh, the h's do reduce, which leaves you with 6x as your first term. Your second term, we see if there's any way to reduce this, and h squared divided by h, one of the h's reduces with the denominator, so it leaves you with just a plain 3h. And then your last term, you have 2h over h, and the h's do reduce, which leaves you with the remaining constant of minus 2. And that would be your result of the difference quotient for this problem. Take a moment to look at it, ask any questions, and then send me a message. Alright, example 6, C. Again, directions, construct and simplify the difference quotient. So again, that reminder, difference quotient automatically means f of x plus h minus f of x all over h. So they gave us the original function of f of x, so what we must find is f of x plus h. And so every time we see x, we replace it with the specified value of x plus h. From here, because these are fractions, we're going to have a slightly different approach. So if you feel the urge to distribute that 2 in the bottom, resist it. Make a little note, do not distribute. So in this case, this is going to be a big, beefy problem, but it's okay. It looks worse than it really is. So let's go ahead and see what we really are dealing with. Our new function, f of x plus h, we are going to plug that in. So here's going to be our new minus our original all over h. Well, our new function was 1 over 2 times x plus h, while our original was 1 over 2x. Now, I'm sure I can speak for everybody. Most of the work and most of the problems and the issues happens to be in the numerator. There's a lot going on up here. So what we're going to do is we're going to focus our energy just on the numerator. Okay, so I'm going to do this on the side. Numerator only. Okay, so if we are just focusing on the numerator, what we currently have is 1 over 2 times x plus h minus 1 over 2x. And if you notice, we have fractions. We have to abide by fraction rules, and because we're being asked to subtract two fractions, we must have a what? A common denominator. Now, we agree both denominators already have a 2, so 2 is going to be part of it. The problem is x plus h is its own value, and x is a separate value. For us to be a common denominator, we need both pieces. So your common denominator is going to be 2x and x plus h. You need all pieces. So I currently have 1 over 2 x plus h, but I'm going to have to force it to be something else with this new common denominator. My second fraction is 1 over 2x, but I'm going to have to multiply it by something to force it to have this new denominator. So this is what we want, but we have to make it happen. Well, if our first fraction has a 2 and the x plus h, notice it already has the 2, it already has the x plus h. What piece is it missing in the denominator? Well, it needs the x. So for that to happen, we have to multiply by x over x. And so in the bottom, 2 times x plus h times x would give me the denominator I want. And so now the numerator, 1 times x, gives me my new equivalent fraction, my new numerator. Now your second fraction, it currently already has the 2 in the denominator, and it already has the x in the denominator. But what piece is it missing? And that would be the x plus h. So we must multiply the numerator by x plus h and the denominator by x plus h. And so 1 times x plus h is going to be x plus h. Again, I'm just abiding by fraction rules. Since we now have a common denominator, we can now merge the two fractions together, and we keep the common denominator of 2x, x plus h. Now here's kind of a tricky part. Be very careful. Whenever you are combining this into one fraction, it is the first numerator minus the second numerator. When you have a minus, sign changes happen. So I can write my numerator as x. Now when I distribute that minus, that now makes that a negative x and a negative h. And so, can the numerator be simplified? And it turns out the x's actually cancel, so you are left with not h, but negative h all over 2x, x plus h. Now, this is the result of the numerator. Now that we have this, we are ready to put it back into the difference quotient. This is the result of the numerator. Now, doesn't that look easy on the eyes? No, that does not look easy on the eyes. So our approach is to rewrite this division. Instead of vertical, we're going to write it horizontal, meaning I'm going to write my numerator divided by my denominator. And in this case, my numerator was negative h all over 2x times x plus h. My denominator is an h. For some reason, just writing it that way looks nice. So now that we see it, we have a fraction divided by a plain number, h. And the only way to divide that is if they are both fractions. So we make h into a fraction by simply replacing it over 1. Now we abide by the rules of fractions. In dividing fractions, we multiply by the reciprocal of the second fraction. So we keep the first one as negative h over 2x times x plus h. But we now change the division into multiplication, and the reciprocal of h over 1 is going to be 1 over h. And now we can multiply. Now when you're multiplying fractions, you can reduce if any of the terms or factors appear in the numerator and denominator. And it turns out we have an h somewhere in the numerator and an h somewhere in the denominator. So those do reduce to a value of 1. There's no other factors that appear on the top and the bottom. So in this case, your answer is a negative 1. Notice we have that negative 1 times 1, which is negative 1. And in the bottom, we have 2x times x plus h times 1. So that just remains. This would be your final result of the difference quotient. Take a moment to look at it, and please feel free to ask me if you have any questions or need clarification. That is it for the difference quotient.